Good morning. This is Jennifer Martinez again, going over section B.1, solving equations. Now, instead of expressions, we're going to look at an equation. If you remember, equation is with an equal sign. The actual definition in the textbook is and the word that goes here is an equation, because that's what we're dealing with, is a statement saying that two expressions are equal. That's why it has an equal sign. A value of the variable that makes the statement true is called a solution. That's what goes there, of the equation. Finding all the solutions of the equation is called solving the equation. If you do the same operation to both sides of an equation, then the resulting equation will usually have the same solution as the original. But you can check your answers to make sure, because there's a few instances where it does not. So that's why they say usually. So let's go ahead and do that. So here's an example of an equation. 16 is equal to 1 plus 5p. And what we're going to do is we're going to try to do the same operation to both sides to isolate the p, to get the p alone. And what I like to do is the opposite of what it says here. So it says 1 plus. The opposite of plus is minus. So I'm going to subtract 1. And then the opposite of multiplication, 5p here, is division. So then I'm going to divide by 5. The order of which you do these is actually in the reverse order of the order of operation. The order of operation says multiplication, please excuse my dear Aunt Sally, right? Addition and subtraction actually is the very last thing on the PEMDAS list. Let me just write that down real quick. So that's why you always undo addition and subtraction first. You undo in the opposite order. What I like to say is, in the morning, I'm going to put on my socks and then put on my shoes. Now, I'm not going to take off my socks first. When you take away, when you go backwards, which is solving, finding the original, I got to take off my shoes first. I got to do it in the opposite order. Then the socks. Okay, so that's why we're going to subtract 1 first instead of dividing by 5. And when you subtract 1 from both sides, as long as you subtract 1 from the left and 1 from the right, it doesn't change the solution. And the left side would be 15, and the right side would be 5p. You get a new equation. It's an equivalent equation. Then what I'm going to do is I'm going to go ahead and solve this equation. This says 15 equals 5 times p. So the opposite now of multiplication is division. So, and I'm going to do the same thing to both sides. If you do the same operation to both sides of the equation, then the resulting equation will have the same solution as the original, usually. And you get p equals 3. You could do a check to make sure that is right. So I'm going to check it. I'll write down my original equation, and then I'm going to put a 3 in for p. I'm going to put a dot there to make it look like multiplication, because we know nothing in between is multiplication. This is going forward. If you know what the original is, I'm just going to look at the right side and simplify that expression, aren't I? So we always multiply first, and then we add, right? So here is simplifying. We multiply first, then we added. In solving, it's the opposite of simplifying. So we're going to do the opposite in the first order. Instead of add, we're going to subtract. That's the first thing we're going to do. And then it says multiply here, so we're going to divide. And that's what I did here. We simplify expressions and we solve equations. So that's how you do that. When you have a equation that is more difficult, it's always best to simplify first. don't try to undo the reverse order with anything with parentheses or anything that is too difficult that has more than one like term. So I'm going to look at each expression on each side and simplify first. So the left side, I'm going to do what we were practicing before, and I'm going to distribute that, get a 6 plus 2p. And even here, I never solve. I like to simplify first. So I'm going to take 1 minus 6. Those are like terms. They're both constants. No variables. So I'm going to add those together. And then I'm going to start undoing. You have to undo the addition or subtraction first. And notice how there's now a p on both sides. This is a little bit more difficult than the one that we had on the left side where the p was already isolated. So I have another goal. I want to do all the addition and subtraction first, but I want to get all the p's on one side. So I have a choice. I can either subtract 2p and put it over there, or I can subtract the 5p and get rid of it here. Because notice if I do that, then let's just rewrite this. 2p and plus a negative 5p, or minus 5p is negative 3p, is 10. These cancel, don't they? So now it looks like part A. So now this is a negative 5. So I'm going to add a 5 here to get rid of that negative 5. And then I'm going to get we really need to talk about this, but I'm going to write this as a negative 3p. Now, why is it negative? Well, if you remember, subtracting a number is adding the opposite. So I'm just going to write that there in red, adding the opposite, because I really, on this one, right, I really am subtracting that 5 if I had that written the other way. If I had this written the other way, it would have been, let's write that as negative 3p minus 5. You can see that's why I chose to add. You don't need to worry about that. You're just going to take the opposite sign when you're adding and subtracting, because I'm just going to see this as a plus negative 5, right? Or, right, adding 5. Subtracting a negative is the same as adding the opposite, adding a positive. So when you add a 5 here, you would have gotten a negative 3p. So when you have this in the reverse order here where the p is on the right side, you really need to bring down that negative. You're just taking away this, right? You can't move things around. Again, when you think of it as subtraction, it always has to be addition. So that's why you need to bring down that negative. When you move terms around, that only works. It's only commutative when you're in addition. Now we're going to divide through by negative 3 instead of just 3, because we wanted to get a p. Negative 3 divided by negative 3 is a p. And so this one would be a negative 5. And you could check that, and it should work. And again, if you're having trouble with negative numbers, you should check out the topic video on how to add, subtract, multiply, and negative numbers before you start this section. Okay, so now we're going to go for solving for a variable in terms of other variables. Sometimes an equation may have more than one variable in it. For example, I have an example of a 12-gallon tank. Suppose you have a 12-gallon gas tank in your car, which contains A gallons of gas before you fill it up. Then you fill it up by buying B gallons of gas. Then you can say that you have A plus B gallons of gas. And since you have a 12-gallon gas, A plus B better equal 12. That is an equation. If A is 9, then you can plug a 9 in for A and solve that equation. So what would that mean? Well, you know it would be 3. You can get that by subtracting 9 from both sides, and you would get b is 3. Again, what we're going to do is the opposite. It says plus, so the opposite of plus is minus. Actually, I like to think of it as adding a negative. The opposite of plus is adding a negative instead of saying subtraction, so that way you don't get messed up like an example B there. What happens when a is 0? When a is 0, you would already have, you don't have to add anything because that would just be a b on the left side. B would be 12. Well, that makes sense because you have 12 gallons of gas. But what if a is an unknown? You can still solve for b, but the solution will be an expression in terms of a, not a number. So for instance, what I'm going to do, notice I subtracted 9, subtracted whatever value is there. If it's a 3, I subtract the 3. So I'm going to just rewrite it here, and then I'm going to subtract a instead of 9. And when I do this, I notice that the a's cancel here. So what I get on the left side is b. I have solved for b. The right side, I realize you cannot subtract those. Those are not like terms. So what we do is we just leave it. And notice how this works. If I put a 9 here for the first one, I get 3. If I put a 12 here, I get 0. It does work. So let's go ahead and try this example 2, where there's more than one variable. Solve each equation for r. So we want to get r alone, and that's its multiplication. So I'm going to rewrite it here. I'm going to divide. It says multiplication, so I'm going to divide by the other guy. Divide both sides by t, because on the right side, you can solve for r on the right or the left, just when it's alone. The left side, you cannot divide those, you just leave it. The right side is an r. This one's a little trickier. Well, first of all, we have 2 r's. So what I'm going to do is get everything that's not an r on the other side. So I'm going to add 5 to both sides. I always want to add or subtract first anyway. Then we do something kind of interesting. We're going to learn what we did last video, which is on factoring. We notice that an r is common, so I'm going to take it out. And I get an a plus 3. And then I can divide. This is multiplication. So I know this is just one term. It says plus there, but I'm just going to leave it as one term. And you can keep that in parentheses, or you don't have to. So r is going to equal to 17 over a plus 3. It doesn't have to be in parentheses as long as you make this line long enough. That would be the answer. So now turn the page to page 9, and let's try some on our own. Exercise 1. Solve each equation and check your solution by plugging it into the original. Try as much as you can and resume when you get stuck. You ready for the answers? Part A. Let's go ahead and do that together. This says what? Division. So what are we going to do? We are going to do opposite, which is multiply. We haven't done one of those yet. So it turns out to be 100, and you can check that on your own. Part B, this says multiplication, so what are we going to do? Let's rewrite it. And I'm going to divide. I'm going to divide not by 24, but by 6, because I want to get the t. So it can be on the right or the left. So it's 4. Part C. What are you going to do there? Well, you want to get all the ends on one side first. So I'm going to add, I'm going to get rid of this one. You could either subtract 6n or you can add 2n. I will add the 2n here. And so we get an 8n minus 3 equals 37. Remember, you always have to do all the addition and subtraction first. So I'm going to add 3, then divide by 8. N equals 5. For the last one, here is the solution. First, I got rid of the parentheses. Then I combined like terms. I decided to add the 6, and then I solve for